Hello, everyone, and welcome to our webinar on moving big data from Snowflake to ClickHouse for fun and profit. My name is Robert Hodges. I work for Altinity, and I will be your presenter today. Before we get into this, further into this presentation, I'd just like to share with you a couple of bits of information that will help you enjoy the presentation. This is being recorded, and for anybody who signed up, you'll get a copy of a link to the recording as well as the slides, so you don't have to take frantic notes. They'll both show up in your mailbox in about 24 hours. Second thing, if you have questions, feel free to post them into the question and answer box or the chat. Either one will do. I'll catch them as we go along in the conversation, and there'll be some time at the end should there be additional questions then. I think those are the main things that I wanted to share. What I'd like to do is go ahead now and jump into the presentation. So we'll start first with a couple of introductions. So once again, my name is Robert Hodges. I've been working on databases for over 30 years. It's actually 38. This year, I tend to say over 30 because it doesn't make me sound so old. But it's been everything from pre-relational databases like M204 all the way to, of course, analytic databases like ClickHouse, which is my current favorite. My day job is I'm CEO of Altinity. I'm backed up by a really, really great engineering team, absolutely awesome experience with databases, particularly analytic databases, and the applications built on them. A lot of what we present at our talks is based on that, on their experience. And then finally, Altinity itself, we are the #1 provider of support and services for ClickHouse in the American and European markets. This includes Altinity.cloud, which is a cloud platform for running managed ClickHouse. Very successful. It's been up and running for close to 2 years. And we are also do a lot of work in the open source community. We are committers on ClickHouse, as some of you may know. We also developed the Altinity Kubernetes operator for ClickHouse, which was the first ClickHouse, or excuse me, Kubernetes operator for a data warehouse, and it really makes ClickHouse itself operate in a cloud native manner. So that's enough advertising. Let's jump into the presentation, and I will start with Snowflake. So one of the things that was fun about this presentation was getting to spend some quality time looking at Snowflake itself. And there are a number of great features in this database. And I'd just like to share a few of them that are most interesting. So first of all, Snowflake is a SQL data warehouse. That's the winning language. And it's not just SQL, but it's a very complete implementation of SQL. So pretty much, most features that you would be interested in for analytics that are in the SQL standard, ClickHouse has them. It runs in the public cloud. So you can run it in Amazon, you can run it in Google, you can run it in, I haven't done it, but I believe you can run it in Azure, of course. So, whichever public cloud is your favorite, Snowflake is there. A really important feature of Snowflake is that it decouples compute and storage. So this was an important innovation, and where Snowflake really was one of the first to recognize that you could store the data on object storage and then pull it up into compute nodes, for example, cache it on SSDs, things like that. And Snowflake is built on that model, resulting in the ability to have relatively inexpensive storage, but then backed by very scalable compute. So you can have, for example, multiple virtual data warehouses which are operating on the same data for different organizations. You can scale them independently, so on and so forth. It's a very powerful model, and one where Snowflake was a leading innovator. They also, because they've been around for a while, have very advanced cloud management. So the system operates very smoothly. You really don't need to know anything about how Snowflake is working internally. You just need to understand SQL databases, and you're off and running. In particular, it is very well suited for star schemas. That's a traditional data arrangement that involve complex queries and what we call large table joins. So these are joins where you might have 1, 2, 3, or even more very large tables, and you're joining information from. This is hard to do and requires a sophisticated query planning process and the ability to shuffle data across a lot of nodes. Two final things. Snowflake has automatic performance tuning. When you use it, you'll notice in the tables, you don't really get to set compression or codecs or any of the sort of under the internal tricks that make data warehouses run fast. Snowflake figures it out for you. And finally, it's proprietary. So you run it in their cloud or you don't run it. There's not like an open source or an installed version. And in particular, as long as you can only run it as long as you have an account with them. So all of these things taken together have made Snowflake hugely popular. And of course, it's backed by a large number of tools and so on and so forth. So ClickHouse is a SQL data warehouse as well. And let's just, if you haven't worked with ClickHouse and are coming here because you're on Snowflake and you'd like to try it out, let me give you some of the key properties. One of them is, oops, I think, I've got an error in the picture, but we'll discuss that in a second. One of the things that is important about ClickHouse is it also understands SQL. The SQL dialect is not as complete as Snowflake, but it's very, very focused on operations that are required to select data off very, very large data sets. So that's an important capability. If you know SQL, you will quickly understand ClickHouse's dialect. Most of the extensions are things that are designed to help with big data. It runs anywhere Linux does. So it can literally run on an Android phone. There was a blog article about that a few years ago, all the way up to clusters in the cloud, in Kubernetes that may contain hundreds of nodes. It uses a shared nothing architecture. And what that means is that the data in ClickHouse, ClickHouse consists of a set of nodes connected by a network, and they each have, for the most part, attached storage. This is something that is actually changing over time. ClickHouse is now, as in the last couple of years, become increasingly good at dealing with table data stored on S3, but it's still primarily a shared nothing architecture and evolving over to that decoupled architecture over time. It's super cost efficient. And if you wanted to pick one difference between that would maybe cause people to think about ClickHouse instead of Snowflake, this would be it. There are accounts on Snowflake that spend tens of millions of dollars a year. It's a very capable database, but Snowflake charges for it accordingly. ClickHouse, because it is open source and because it's extremely parsimonious in the way that it uses resources, is ideally suited for to be the back end that handles, for example, SaaS analytics, where you have hundreds or thousands of tenants and you need to provide each of them a dashboard. And this cost efficiency comes into play there. It has extremely fast data ingest. I'm doing another project. I was loading data, had to load 1 trillion rows of data. I'm able to load them on a moderately powerful host at about 73 million rows per second. This is really fast. And together with that fast ingest, if you design for the types of applications that ClickHouse supports very well, which tend to be very, very large time-ordered data sets like observability data, market data, things like that, you can build systems that really give you linear scaling as you add more resources and with a fixed query response. This is very, very important for applications that need to respond in real time, like real-time marketing or generating metadata for financial applications, things like that. And then finally, it's open source. It's Apache 2.0, which permits, basically permits you to use it for any business purpose with relatively few limitations. So the result is ClickHouse has become a phenomenally popular engine for real-time analytics. There's a number of verticals where it's widely used, and and the popularity is literally increasing every month. So with that, sort of overview and background, which I hope is helpful, what I'd like to do is just talk about what the rest of this talk will cover, which is just move data that's in Snowflake to ClickHouse via object storage and Parquet. Now, there are a number of ways that you can move data. So for example, ClickHouse can actually read directly uh, out of Snowflake tables. You can, if you want to, you can install the Snowflake ODBC driver uh, on the same host as ClickHouse, and you can actually select data out of Snowflake tables. The problem with that is that it's pretty slow. So you have a single network connection. You're affected by bandwidth latency between the Snowflake and ClickHouse. It's not a particularly a good way to move large amounts of data. There are other ways you can do it, but for moving data in bulk, generating Parquet files, and we'll get into what that format involves. It's a sort of a portable format for columnar data, and putting it in object storage is a great way to move non-trivial amounts of data. And in fact, in the example that we're going to show, that that's sort of like the leitmotif throughout this talk, we're moving 150 million rows. So not a large data set, but not small either. So let's get going on the first step, which is to get the data in Snowflake, out of Snowflake, and into Parquet files in S3. This is actually pretty easy. So here's the process. What we're going to do is we're going to take a table called orders, which is actually a TPCH table that's included in the sample data set, that if you're running Snowflake that was started anytime in the last 2, 3, 4 years, you should have this table just available. And we're going to copy it into what's called a stage. A stage is an entity or a resource that you can define in Snowflake that basically is connected to a location in object storage. And by using the copy into command and moving the data over, it will then cause it to be written to S3 object storage, and in this case, in Parquet file format. So let's show the steps to do that. It's really as simple as it looks. So here's the source table, just so you know. This was what happens if you run a describe table. So it's orders, and it has a few numbers, a few varchar or string fields, and a date. So pretty simple table, 150 million rows. It does not contain nulls, as it turns out. As you can see, everything is none of the columns permit them. That'll have consequences later on. So the first thing we want to do when we want to move that table is we're going to go ahead and create one of these stage objects. And for that, to make sure that things to stay organized and not mess up other things, I'm going to go ahead and create a schema called S3. Schema, if you're familiar with this, is kind of like a folder. It's a level between a database and a table in Snowflake. And then what I'm going to do is run this create or replace command, and this creates the stage. So I give it a name, I give it a URL in S3. So there's your migration bucket, that's substitute your name. I have to give it credentials so that Snowflake can learn how to can know how to write to it. And then a really important feature here is I'm going to set the file format to Parquet. And what that says is anything that is copied into this stage is going to get written out as Parquet files. That's pretty convenient because then we don't have to worry about it. It'll just do the right thing. We can, by the way, use the stage to read data back in, and we'll show an example of that in just a second. So that's the first step. We create and presumably the bucket you've gone off and created before, but here's the stage that can now write to it. The next thing is copy the data, and this again is really easy. So you use this copy into command, which is a pretty standard SQL feature. Most databases have some version of this. So what you're going to do is you just say, hey, I want to write it to, that @ sign says directs it to the S3 bucket, which the stage that we created. And then here's this longer name here is basically going to be the path that's going to be used in S3 to write the files. So, and then we can say from, and that just says, hey, suck all the data out of this table. What's kind of nice about copy or copy into is you can also use a select statement there. So if you had conditions on the data that you wanted to move, you can just have a select that selects what you actually want. And then here's an important setting, this header equals true. What this basically tells you is store the column names in Parquet. That's important because we're going to use them later to generate a table inside Snowflake. So that's it. You let that command complete, your data will be written out. And what you'll see if you go out to S3 is a bunch of Parquet files, which are, like sort of, pretty much the same size. The size difference, there's some difference depending on how much data, but you'll get a bunch of them. And then what you can do is just check that they all got out there. So what I like to do is do a select count off the original table orders. And then what's kind of cool is you can do a select count from the S3 bucket. This is not a very fast command. I'm using a small Snowflake installation, so that probably doesn't help, but this can take a while. But if you see these come back with 150 million rows in each case, the numbers match, you got all the data written out. So that's it. At this point, the data has left the building, as it were. It's sitting out in S3 as Parquet files. So what we're now going to do is go load that Parquet data into ClickHouse. So the first thing that we're going to do is just show you the basic steps. It's actually even simpler in some ways to pull the data in, because we have in ClickHouse, we have something called the S3 table function. So this is a function that you can select from, and it will point to, you give it parameters that point to a location in S3 that you want to read from. And so in ClickHouse, we don't have copy into, we use insert into to move the data. So we're going to do insert into, and then we're going to have a select statement off this table, and it's going to put this into the orders table over on ClickHouse. So let me just check that I've still got proper audio. Great, looks like the audio is on. Let's continue. All right. Okay, so before we were interrupted by a large delivery, we were talking about how to move data out of S3 via the table function into a table orders. So let's look at the specific commands in ClickHouse. All right. First thing we need to do is we actually need to create the table. And so what I have right here is a create table command using ClickHouse syntax. This is something you can create manually without too much trouble if you're just using one table. But if you had a bunch of these tables, or the table were very complex or particularly large, this is not something you'd want to do yourself. So I'm going to show you a way to generate the SQL in a minute, but let's just take this as an example. And one thing that if you know ClickHouse, you'll look at this table and you'll say, hey, this is awful. So for example, this is a huge value here, an int, 128-bit int. We don't do anything special on compression, so we don't take advantage of ZSDD, for example, if it's appropriate. And most importantly, there's no partitioning or sorting. So if you've used ClickHouse, you know that one of the things that's really important with ClickHouse is to define, first of all, how tables are broken up into pieces. We call these parts. So that's your partitioning key. And then also define how they're ordered. So using order by, which also defines what's called a primary key sparse index that can help you find stuff based on the row order. So we're not going to specify any of these things, and we're just going to dump the data into ClickHouse. What we'll then do is fix it up in just a couple of minutes so that it's more efficient. So we've got that. If we run that table command, then the next thing we want to do is pull the data in from S3. And here's how you do it. So you're going to do, as I mentioned, an insert into orders using from a select. And so we're going to select star. So we're going to go ahead and select all of the columns. And this S3 function, as you can see, has a number of parameters. This is a table function. So the results that come back from it are rows. And we give the full path of the, out to the location in S3. And one really cool feature here is we can wildcard. So you see star.parquet. This means that we can go ahead and you know, read a bunch of files at once. We also provide our access key and our secret key, and then tell the S3 function that we're reading Parquet. That's going to be what's called our input format. There's another really important setting here when you're loading data into ClickHouse, which is max insert threads. So I was actually reading this in a 32 vCPU machine. I could have actually set it up higher, but in this case, I just went with 16. Pull it in, which means that it will read these, what turn out to be hundreds of files, in parallel and get the data loaded that much faster. So this is the command you use when there are no nulls in your data. It turns out that due to an issue with reading Parquet in ClickHouse that is logged as an issue and will eventually get fixed, if you have nulls, the S3 function isn't able to cast the data correctly. So it will kind of spit at you and say, hey, this, I can't read from, this nullable data that I'm seeing out on Parquet. I can't read it into non-null data because it just doesn't know what to do with it. And here's the GitHub issue. In that particular case, what you're going to do is have to help the S3 function a little bit by actually generating including a string that shows the column format of the data that you're reading. This is a temporary issue and will be cleared up in due time. So either way, that loads the data into S3, and then what you can do is, once it's loaded, you'll go ahead and just check your work. And in this particular case, when I ran it, it was 150 million rows. So data loaded, ready to roll. So at this point, you've got the data inside ClickHouse. And our next step is going to be to look at it, because it's much easier to look at the data inside ClickHouse when we can run queries across it, look at the data types, examine compression levels, than it is when it's living out on Parquet. But I'd like to take a short detour and talk about Parquet itself and how it works. So let's just jump in and talk a little bit about how Parquet is organized. So Parquet is an open source format that originally came out of one of the Hadoop projects, but it's basically a file format for columnar data, and it's quite efficient. So what we have here is 3 Parquet files. So, and if we look at one of them, if you go take them apart, and sort of at a high level, what you'll basically see is groups of rows. So it's called a row set. And within the row set, there will be data for all the columns for a certain number of rows. And then you'll have another row set, again, with all the column data. And at the end of the file, you'll have metadata. So the reason it's at the end of the file is it allows Parquet to write all the data out, and then it can write the metadata after it's seen all the data that it wrote. So it knows what metadata it needs and what it should look like. One of the features of this is that this metadata is very generic. So it gives things like column names, data types, whether the field is nullable or not. These are things you can read quite easily. And there's a bunch of libraries. I use PyArrow to do it, but you can actually read the metadata and then actually create a table definition from it. Still on Parquet, you can have a group of Parquet files together. We call that a data set. And it really means that Parquet is perfectly happy most libraries are perfectly happy to read a single file or to read a bunch of them. But when we're reading Parquet, we can just have point to some path out in S3, and then we can read all the files together because Parquet has the libraries that access Parquet can deal with multiple files at once. Okay, so in order to finish this project, one of the things I did was I wrote a script that would actually generate the table definitions as well as that S3, that command to load from S3. You can get hold of this pretty easily by just cloning this project. The script is very simple. It's really only been tested on this stuff, but it's something that you can use as an example for how to do this. So you can go clone the project, and then it's written in Python. So what you want to do is typically set up a virtual environment called .venv. That just gives you a scope in which to run Python and ensures that your libraries are present. So you run those commands at the command line on your favorite Linux host. And then you'll set a few environmental variables. These are the ones that you need to set. And these will tell the script what to do. Like, where's your data? Like your S3 is out in US East 1. Here's your access key, secret key, and then a path for in S3 that we'll use to read the data. And the path is defined as database, schema, and then table name. So very standard. And it means that if you then have a bunch of tables, it's pretty easy to then change that path, to store each table in a separate, under a unique path in S3, and then read the table files in conveniently. Once you've done that, you can just run this Python generate ch schema.py script, which uses the PyArrow libraries to read the data set and figure out what the column names. And then what it'll do is it'll generate a create table statement for you, as well as that S3, as well as the command to insert by selecting from the S3 function. It will put your keys in and just generate this kind of gnarly, take care of generating this kind of gnarly syntax. You're free, of course, it doesn't actually run the commands for you. It just prints them. So you're free to modify them and then just stick them in your favorite client and run them. So that was Parquet. This gets us to the final step, which is to optimize the imported table. So one of the things that we want to do in ClickHouse, and again, if you're coming from Snowflake, it's important to realize that Snowflake makes a lot of choices for you. That's actually one of the powers of the product. In ClickHouse, you have incredible power to optimize performance, but you need to do it by making explicit choices about the data types you use, your compression, codecs. So this gives you an example of how we actually do this to alter this table to make it more compact and more performant in ClickHouse. So what we did is we have a new table called orders optimized, and for example, it uses smaller data types. So instead of 128 bits ints, we're going to use 64. We could actually go to 32 probably, and that would be fine. But I don't want to make any assumptions about how many orders or customer keys there are. Other things we could do. This is invokes ZSTD compression. So this is really sort of invoking, sort of providing a higher level of compression on the string. That may be worthwhile, particularly if you have a lot of string values. It is a more expensive function, but it saves a lot of space. The other thing that we do is we actually get the partitioning and the order by correct. So in this case, in ClickHouse, it's pretty common that if you have time ordered data, you'll store it by, you'll partition by month, for example. That's suitable for this data set. There's because it spans a number of years. So you'll go ahead and take the order date, turn it to a month, and that's how you break the table up into parts. And then finally, the order by, we're going to I picked one, order it by the order date. So it's time ordered, and the customer key. This means that for queries that have anything to do with the date on which the order is made or the customer who made it, we're going to find them really quickly. So that's very efficient and will cause us in some cases to get also much better compression. So when we do this, we can just set this up, and you can either reread the data from, sort of substitute the table definition and reread it from S3. That's one possibility. What I'm going to do is actually just read it from the table that we created in the first place. So again, set the max insert thread so that I can parallelize. And then basically, I'm going to just select from that original orders table and put it in, insert it into orders optimized. That will get my data in. And then what I'm going to run here is this. You don't have to do this, but ClickHouse has a command called optimize table. And what that does is it forces with the final keyword, it forces all the parts that get generated to be merged so that they're kind of at an optimum, what ClickHouse considers to be an optimum size. This is useful to do if you're trying to test whether you've got the, whether you've got the performance right on the table without having to wait for ClickHouse to merge all the data for you. So, because it'll merge over time, but this will force it to happen right away. So once we do this, you can now check the table size. So before and after optimization. And ClickHouse has these wonderful system tables. There's in fact system dot tables. It's a table that gives you metadata for all tables in the system. And what we're going to do is look at just compare the sizes of these tables that are begin with orders. So that's orders and orders optimized. And you can see that we started with the first one. We had a size of 6.6 gigs, and we got it down to 4.37. That actually turns out those optimizations I did on the table turn out to get it within 2% of the size that Snowflake records when you go look at the table in the Snowflake client. So that's pretty good. It also reflects well on Snowflake because Snowflake does this. I mean, I'm sure they played around with it, but Snowflake does that kind of optimization more or less automatically. So at that point, you basically are done. This is how you moving data from ClickHouse or excuse me, from Snowflake to ClickHouse is actually not that hard. As long as you have S3 and you can write it into Parquet, you can move large amounts of data pretty easily. And in fact, the process is really 3 steps if we want to summarize it. First is set up an S3 bucket. Then in Snowflake, create a stage and copy the data from your Snowflake table or tables into the stage. And then on the ClickHouse side, make a working table definition, load data from that using the S3 function. These first 2 things you can generate using that script I described. And then finally, what you're going to want to do is optimize the schema and reload. So what I suggest doing, if you're doing this in anger with large amounts of data, you'll probably just read a portion of the data from S3, just enough to see it, play around with it. ClickHouse is very quick on, for example, when I'm doing this kind of work, I tend to, try to keep it, sort of in the few hundred million rows range so that it's a non-trivial amount of data. You'll see differences in query speeds, but it's not so large that you're spending, like hours waiting for stuff to load. And yeah, at that point, you're ready to build applications and start trying out your data on ClickHouse. So a little bit about documentation. We have the Altinity.blog. This talk is actually largely based on a blog article that I wrote with Snowflake. That was an accident, Snowflake. The SQL examples, which you can get from GitHub. And then beyond documentation about Snowflake itself, which, if you use Snowflake, you're probably pretty familiar with. If you want to dig more deeply into this, the Apache Parquet and Apache Arrow are 2 good places to look. Parquet, of course, explains how Parquet works. And then Apache Arrow provides really handy libraries for reading Parquet data. They're widely used, and the Python libraries are quite good and pretty simple to use. So, excuse me, with that, this talk is done. So if you have, I don't see any questions. Here we go. Why not? Great one. Yes, a question. Why not import into the optimized table directly? That's actually a great question. The reason that I didn't import to the optimized table in this case was that it turns out that when you're optimizing things in ClickHouse, you often need to have a few passes through it, and it's just simpler to do everything inside ClickHouse itself. So what I'll do is I'll play with the table, I'll truncate the data, I'll select it in from the from the unoptimized table, and then I'll compare the sizes and maybe optimize it again, In fact, let me show you something to illustrate this. Let me show you just something, kind of the process that you go through here. I'm going to go ahead and we're connected to ClickHouse. So let's see, do show tables. There we are. We do orders and orders optimized. I'm going to just run a query. Let me go grab the text for it. 1 second here. What I want to show you is the kind of analyses that you run to check the sizes of the table. So 1 second here while I pull the file up. All right, so here's this is the query that I ran, I showed in the slides. So this one right here figures out the size of the table. That's pretty useful, but here's a much more useful one which shows you, sort of the level of detail you tend to go to. Let's pull this one in. This is actually going to look at individual columns. This is a more interesting analysis. What we're doing here is actually looking at the differences in this in the amount of storage in columns. So you'll tend to do this a few times before. If you have a very large table, you'll play around with this a little bit to get the data to a nice size. And you can see things like, for example, order key. For example, the uncompressed, this is the amount of the uncompressed size. In the original unoptimized table, it was over 2 gigs. It was down to about 1. When we reduce the size of that key. There are other cases where we simply get better compression. So let's look for an example of that. Here, don't have too many. Here's one where the compression, the amount of data that we ended up with on disk ended up being about half what we had in the original table. It's, so you can see that. These are the kinds of things you play around with. Okay. And then, of course, you can run queries on the table, things like the following. This is connecting via the cloud, so it's a little bit less, so the queries are going to have some latency as we cross the country from California to US East 1. So the numbers aren't super meaningful run through this client. With that, any other comments I'd be happy to, or questions, I'd be happy to answer them. And what we can do in the meantime is, if you have further questions on this and would like, to chat with us about it, feel free to contact us. You just come to altinity.com. You can send me email directly if you're interested in this talk. Once again, we run altinity.cloud, so we can give you a ClickHouse platform that you can try this out on. We do complete software and support for ClickHouse, everything that's necessary to get applications, analytic applications to run on ClickHouse, and we're hiring. So with that, that's all that we had on today's talk. I wish you the best of luck with moving data from Snowflake into ClickHouse, and let us know how it goes. We'd love to hear from you, and look forward to talking to you about your projects. And with that, I'm going to go ahead and close since there don't seem to be any other questions coming up, I will go ahead and close this session. Thank you very much. You'll see links appearing in email within the next 24 hours, and enjoy the slides and recording of this presentation. Talk to you soon. Bye.